everyone! Today, we will be learning about linear transformation of a matrix. But before anything else, let me introduce myself. My name is Eliza Gil Handayan. I am 21 years old. I graduated last 2019 at Davao Oriental State College of Science and Technology, or known now as Davao Oriental State University here in Mati City. And I'm also connected and affiliated to Mati Polytechnic College Incorporated for more than 2 years. And now, let's define what is linear transformation of a matrix. So our goal here is to identify and construct a linear transformation of a matrix. So this linear transformation has a special kind of mapping in which it composed of two properties. So the first one is a matrix addition and the second one is the scalar multiplication. So we have here the definition of a linear transformation. So let V and W be a vector spaces. So a function L of V into W is called a linear transformation of V into W. So this definition will be achieved if those two properties will be attained. Okay? So now if L times the quantity U plus V is equal to the L times U plus L times V for every U and V in vector space or the V. And also L times CU is equal to CLU for any U in V and C any real number. So as what you observe, the A it expresses a matrix addition, and the B it also expresses a scalar multiplication. Okay, we have here an example. So let L, or the linear transformation of R3 to R3, be defined by L times U sub 1, U sub 2, U sub 3 is equal to U sub 1 plus 1 to U sub 2 and U sub 3. So as you can see, as you observe, that it is in the form of a matrix. So to determine whether L is a linear transformation, so we will let some matrix. So we have here the U is equal to U sub 1, U sub 2, and U sub 3, and V is equal to the V sub 1, V sub 2, and V sub 3. So as you observe also that in that given, we assume here, because of the given example, the R3 to R3. And when you say R3 to R3, so it is in the form of in that given example. So now we will solve this one. So we will use the first property, which is the matrix addition. So L times U plus V is equal to L times U sub 1, U sub 2, U sub 3 plus V sub 1, V sub 2, V sub 3. Since it is in the matrix addition, so we will add those elements of the matrix U and the elements of the matrix V. So we have now here L times U plus V is equal to L times the matrix U sub 1 plus V sub 1, U sub 2 plus V sub 2, and U sub 3 plus V sub 3. So we have now here, so we will substitute those definition of the L R3 to R3. So U sub 1 plus V sub 1 plus 1, 2 times the U sub 2 plus V sub 2, and U sub 3 plus V sub 3. So we are next, on the other hand, so if it's in this form, the L times U plus L times V is equal to U sub 1 plus 1 to U sub 2 and U sub 3 plus V sub 1 plus 1 to V sub 2 and V sub 3. So this in that form, so the L in that form, so we substituted the definition of the given example. And after that one, we do the math. So U sub 1 plus V sub 1, we combine them through the matrix addition. So U sub 1 plus V sub 1, and then 1 plus 1, we have 2 there. So, and next, we have to combine the U sub 2 plus V sub 2 and multiply by 2. And also the U sub 3 plus V sub 3. So in that case, the given example is not a linear transformation. It's because it is not equal. Okay, so if we have an example, if we let some values of the u sub 1, v sub 2, and the v sub 3, so it is not equal. Okay, we have here, for example, we will let some values of the v sub 1, v sub 2, v sub 3, and the u sub 1, u sub 2, u sub 3. So suppose that we have u sub 1, the u sub 1 is 1, the u sub 2 is 3, the u sub 3 is negative 2, the v sub 1 is 2, the v sub 2 is 4, and the v sub 3 is 1. So we substitute those values in the given variables, the u sub 1, or those given elements of the matrix. So we have here, substitute those values. So we have now 1 plus 2 plus 1, 2 times the quantity 3 plus 4, negative 2 plus 1. So in the form of L times the quantity u plus v is equal to the matrix of 4, 14, and negative 1. So as you can see, in the 4, 14, negative 1, it is in the form of the 1 by 3. 1 by 3, it's because the given example is R3 to R3. So the matrix is in the form of that example. And then the next is, if we use the distributive property, the L times U plus V, so we will use the distributive property L times U plus L times V. So diba, we have there U sub 1 plus V sub 1 plus 2, and 2 times the quantity U plus 1, U sub 2 plus V sub 2, and then the U sub 3 plus the V sub 3. So we substitute those given values, the U sub 1, which is the 1, the U sub 2, which is the 3, and the U sub 3, which is the negative 2, and the V sub 1 is 2, the V sub 2 is 4, and the V sub 3 is 1. So let's substitute and do the math. So we get the L times U plus L times V, the 5, 14, and negative 1. So it's L times U plus L times V. I'm sorry for that error. So here we have the matrix 5, 14, and negative 1. So the first one, it's 4, 14, negative 1, and the second one is the 5, 14, and negative 1. So the given example 1, the linear transformation of R3 to R3 is not a linear transformation. Okay, now we have here another example. So let the L, or the linear transformation of R2 to R2 be defined of L times the matrix U sub 1, U sub 2 is equal to the U sub 2 sub 1 and U2 sub 1 and 2U sub 2. Sorry for that. So let us know, we will know rather, if that example is a linear transformation. Let's solve this one. So let U is equal to the U sub 1 and U sub 2, and V is equal to the V sub 1 and V sub 2, since the given there is R sub 2 and R sub 2. If in that case, the rows there is 2 and the column there is 1. Okay, so then so through matrix addition, L times U plus V is equal to L times U sub 1, U sub 2 plus V sub 1, V sub 2. So L times, so we have to add them both. So U sub 1 plus V sub 1, U sub 2 plus V sub 2. And then, so through the definition of R2 to R2, so let's substitute that one to the matrix there. So U sub 1 plus V sub 1 raised to 2 times 2 U sub 2 plus V sub 2. So on the other hand, if we distribute the L times U plus V, so LU plus LV is equal to U sub 2, U2 sub 1 to U sub 2 plus V2 sub 1 and 2V sub 2. So here, substitute again the definition of the example. So you have there the U sub 2, sorry for that, u2 sub 1 plus v2 sub 1, and then the next column, the row is 2 times u sub 2 plus v sub 2. So there are some choices of u and v such that L times u plus v is not equal to LU plus LV. And we conclude that the L is not a linear transformation because if we let some values there, that is not equal. So, from the given na lang sa gihatag din haa, no? So, dili jud siya mag-equal. Una siya ang iyahang unsa ni kay lahi lang man tong u2 sub 1 and v2 sub 1 and the u sub 1 plus v sub 1 quantity raised to 2. Okay? So, lahi lang jud to siya. No, so that example is not a linear transformation. Okay, so any of those properties, it's either the matrix addition or the scalar multiplication, can be a tool in identifying a linear transformation. Now, we have here a theorem in order to know more about the linear transformation. Since our goal here is to identify and construct a linear transformation of a matrix. So we have here a theorem. Let T be a linear transformation, then there exists a unique matrix A such that T of X is equal to A X, and for all X is an element of real number n. So every linear transformation actually can be a thought of a matrix transformation. In other words, from real numbers, if we have from Rn to Rm, the Rn is the R column and to R row. And T is a transformation, then there is some matrix that would give you the same result as the transformation on any arbitrary vectors. So in other words, the transformation times an arbitrary vector is going to give you the same thing as the matrix times the vector. And for every linear transformation, there is a unique matrix that the linear transformation is going to give you the same result as the matrix multiply it times the vector. So we will understand those definitions through this example. So we find the matrix. Okay, we will let T be a linear transformation by the following. So find the matrix A such that T of X is equal to AX. So we have here the linear. So you can see, so we will transform that one into a matrix form. So we have data T times x sub 1, x sub 2, and x sub 3 is equal to 5x1 minus 2x sub 2 plus 6x sub 3 and negative x sub 1 plus 4x sub 3. So we will form that one into a matrix, or we will find the matrix of that given. So how here now? So since we have we call that one as the E sub 1, E sub 2, E sub 3 if the m by n or the row by column is the 1 or the 3 by 3, 2 by 2, 1, so on and so forth. So here, since it is in a form of 3, so we have there 1, 0, 0, 0, 1, 0, and 0, 0, 1. So we will that linear transform, the given example, we will transform we will find the matrix of that given example. So to determine the matrix or to find the matrix, so we have there the identity 1, 0, 0, 0, 1, 0, and 0, 0, 1. So we will substitute there the 1, 0, 0, since first column is a 1, 0, 0, so we will substitute it in our linear form of matrix, right? So 5 times 1 minus 2, since 1 there is the beginning of the matrix, so 1, and then substitute the 0 there to the x sub 2, and 0 is in the 6x sub 3. So since we have here the x sub 1, x sub 2, and x sub 3, and the identity form there is 1, 0, 0 since it's in the first column. So let's substitute And also in the negative x sub 1, so we have 1 from the x sub 1, and since there is no x sub 2 there, so let's leave it be and let's continue the for x sub 3. So since the x sub 3 is 0, so we will substitute 0 to the value, to the x sub 3. So we have now there, let's do the math. So we have now here the 5 times 1, we have 5, and negative 2 times 0, we have 0, so we will not include it anymore. And 5 plus, sorry for that, so plus 6 times 0, so 0. And since we are looking for the first column of the matrix, excuse me, and so next there, the second row, negative 1 times 1, and since there is no x sub 2, so let's continue to the x sub 3. Instead of 4 times 0, so 0, so we will not include the 0 anymore. So the first column of the matrix A is 5 and negative 1. So we will proceed to the second column. So we have the 0, we have the identity 0, 1, 0. So just like what we did, we substitute there the given, the x sub 1, x sub 2, and x sub 3. So 0 for the x sub 1, 1 for the x sub 2, and 0 for the x sub 3. So we do the math and we get the negative 2 and 0. And just like the other, also we have there the 0, 0, 1. So since it's the E3, the identity matrix 0, 0, 1, we have there just like what we did for the second column and the first column, we substitute the values of the given. So 0 for the x sub 1, 0 for the x sub 2, and 1 for the x sub 3, and we get the third column of 6 and 4. So we have now here the matrix 5, negative 2, 6, negative 1, 0, and 4. So that is the matrix A of the given example. I hope you learned something from me today. Thank you so much for listening. God bless us all.